Welcome. This is part 2 of the inference review for my Math 1600 statistics course. So we are on number 3 here, and I have the information, so I'll go and let you read through that. I forgot to put a problem on this review sheet that had a sample size that was less than 30 for using a t-test. So there will be one on the test that will be less than 30. This one's 31, but there will be less than 30. So I'm gonna treat this one as if there were less than 30 in the sample size. So the the work that I'm gonna do is using the t-distribution. Okay, so I could still use it. It's just not necessary if I have a larger sample size. So just remember that on my test, it will be less than 30. You use a t-distribution, and this is the example of the t-distribution one. So first of all, we're going to find a 95% confidence. So in a t-distribution, we're going to use x bar plus or minus t star standard error. Now the standard error is the same as the last one, but the degrees of freedom is n minus 1, which is 31 minus 1, which is 30. So we need to find the t star for 95% confidence with 30 degrees of freedom. So we're going to go to our t-table. Here's my t-table. Hopefully you can see this. Let me throw this out of the way. I'm going to go to 30 degrees of freedom, so right here. And I'm going to go over to 90%. What do we want? 95% confidence? Okay, so 95% confidence. So look right here. Oh, sorry, right here, 30. And I'm going to go over, and now I'm looking down here, 90. Okay, so 90% confidence, and 30 is going to give me a value of 1.697. So you see it's pretty close to the z star. Okay, so 1.697. And I got that from my t-table. So I'm going to multiply these together, and I'm going to work this out in my calculator to get my confidence interval. All right, and then I'll write down, we'll write down our confidence interval in context, because that's what we want to make sure we do. Write it in context, right? So let's go ahead and calculate this out and write it in context. So we're going to get 58.0326 and 66.561. So I'm going to go ahead and write this in context. Get away, I don't need you. All right, so we are 95% confident that the true mean emission for X-ray machines is between, because I already said mean or average, is between 58.0329 millirads and 66.5671 millirads. Okay, so that is our confidence interval in context. Let's here so we can see it. Okay. Move around here. All right, so now that we have that done, let's go and go to B, which is our our significance test. We're going to test whether the population mean emission is too high using an alpha level of 0.05. So we're going to have our null hypothesis, which is the mu of the emissions, is equal to 60. I got 60 from right here. This is the population, right? That's the population mean average. So that's what we're going to be equal to. Now we're going to see if it's bigger than that. Is it too high? Do we have too much emissions? So we're going to say that the mu of emissions is greater than 60. That'll be our alternative. Okay, our conditions. We do have a random sample of X-rays. 31 X-rays is definitely less than 10% of all X-ray machines. And we're going to go and assume the population is nearly normal. We don't know that, but we are given its mean and standard deviation. So our t value is going to be 62.3 minus 60. Okay, so this is our x bar minus mu, over 14 divided by square root of 31, which is our standard error, okay? Our standard deviation of x bar. All right, so we're going to calculate that in our calculator, and it's going to get us 0.915. And then we're gonna check to see what the probability of that is with 30 degrees of freedom. All right, and we want to see that the probability of t with 30 degrees of freedom is greater than 0.915. And you know what? This is a pretty small t value, so we're already going to think that our p-value must be too high. But let's go and check that just in case. And we want to make sure we check it. So we're going to go to our t-table. And we're looking for a value of a t-value of 0.915 with 30 degrees of freedom. So we're going to go to 30 degrees of freedom, and we're going to look in here till we find 0.915. Now 0.915 is in between here. So we're going to go up here. We've got 0.20 and 0.15, so we're going to add those and divide by 2. 0.20 plus 0.15 divided by 2 is going to give us about 0.175. So that's a close approximation to our p-value, which is going to be, obviously right now it's going to be close enough because you know, we're definitely going to be lower than our alpha level, or sorry, higher than our alpha level. So we're going to go say 0.175, which is definitely greater than our alpha level, which was 0.05. All right, so now for our conclusion. All right, that thing. So our conclusion is that since our p-value of 0.175 is larger than the given alpha level, we fail to reject the null hypothesis. I'll move this up in just a second, because I know you can't see that. So what does that mean? That means that there is not enough evidence that the mean emission is, can't spell, is too high. All right. Okay, so there's our confidence, our hypothesis test for a one sample mean. This is going to be small samples because we're using the t distribution. All right, so let's take a look at the next problem. Okay, so this one we won't need to take too much time. If the p-value for a t-test for a test is p equals 0.03, give a conclusion, either reject or fail to reject for each of the following values of alpha. So for an alpha level of 0.10, is the p-value bigger or smaller than 0.10? Well, 0.032182 is smaller than 0.10. So if the value is smaller than 0.10, we are going to reject the null hypothesis. Okay, so this is A. So let's talk about B. 0.032182. That's going to be less than 0.05. So we reject the null hypothesis. Well, in C, 0.32182 is greater than our alpha level of 0.01, so we fail to reject the null hypothesis, okay? So if it's greater than our alpha level, we fail to reject. If it's less than our alpha level, we reject the null hypothesis. A statistics professor wants to see if more than 80% of his students enjoy taking his class. At the end of the term, he takes, I wonder who that stats professor is. He takes a random sample of students from his class and asks, in an anonymous survey of course, if the students enjoy taking his class. let's write the null and alternative hypothesis. So the null hypothesis is going to be that the proportion of the students in his class is equal to 0.80. And the alternative hypothesis, well, let's think about this for a second. If the proportion of students is equal to, we want to know if more than 80% liked his class. So we're going to make our P proportion of students greater than 0.80. If this said to see if there was a difference, then we'd make that not equal to. If we wanted less than 80%, we'd say less than. Now, you could put less than or equal to, but again, some books are different. I choose to use the equal sign. All right, so those are the hypotheses for number 5. I'm going to go and do numbers 6, 7, and 8 on another video. So we'll do a part 3. So that's it for part 2. I'll see you in the next one.